Hi, it's Dr. Weideman again, and I'm going to show you how to use StatCrunch to work some problems from Chapter 20. Chapter 20 dealt with comparing two samples, either for proportions or for means. So the first problem we're going to look at is problem 40, homework problem 40 in your ebook on page 575. And let's just take a look at the problem over here so we can see the description of what the problem's about. Okay, so 1 month before the election, a poll of 630 randomly selected voters showed 54% planning to vote for a certain candidate. A week later, it became known that he had had an extramarital affair, and a new poll showed only 51% of the 1,010 voters supporting him. Do the results indicate a decrease in voter support for his candidacy? Write the hypotheses, state your conclusion, test the hypothesis, and we'll also do a confidence interval. So the hypothesis, we've got a before poll and an after poll. So the null is going to be that there's no difference. And then the alternative, they're wondering if his poll numbers dropped. So if they did, then we would expect the difference between the before and the after to actually be positive. And if you remember in the description, it was 54 and it had dropped down to 51%. And assumptions and conditions. Random, independent, it said they were random polls, so we should be okay. Independent should be fine. The two groups are independent. We're going to assume that they use a different group of people to survey the second time around. 500 to 1,000 should be less than 10%. And we need to check the success failure for each group. So the before group, there were 630, and the p-hat from that group was 54%. And so if we calculate our successes, we get 340. And our failure is 290, and so they're both greater than 10. And likewise for the after group, 1,010 were surveyed, 51% was the sample proportion, so the successes are 515, and failures are 495. So both of those are good. So we can go on over and pull up StatCrunch, and we're going to go ahead and we're going to do proportion statistics to sample with summary. Now if you remember, we have to put in the successes for each group, and we're going to do the before group first, and the successes there were 340, and the sample size was 630, and the after group had 515 successes and 1,010 observations. We're doing P1 minus P2 equal to 0, and then remember our alternative was greater than 0. So let's go ahead and compute. And so what do we get? We get a z-score of 1.17 with a p-value of 0.12, and we said to use alpha of 0.5. So in that case, we would fail to reject, and we would say that there was not a significant difference in the poll numbers before and after the announcement of the candidate's extramarital affair. Let's go ahead from the same window and do the confidence interval. So if we just scroll down in the window and we move over to the confidence interval, now notice what we see here. We see that the interval goes from about negative 2% up to positive 8%. So it encompasses 0, which agrees with what we found in the hypothesis test. Okay, let's go over and let's do a problem on means. So that was proportions, two proportions. So now we're going to look at two means. And this problem is looking at the use of a drug to improve your memory. Actually should be homework number rather than 69. It's actually 70 in your ebook. Let me go ahead and pull that up. And it's on page 580. Okay, so it says Dinkoba enhanced memory. In an experiment to find out, the subjects were assigned to randomly get those supplements or a placebo, and then their memory was tested to see whether it had improved. Here are the box plots comparing the two groups. And we're going to go into StatCrunch and work on it over there. But let's go back and talk about what our hypotheses are. So our hypotheses are that the ginkgo minus the placebo, that should have a mean difference of 0. And then if that drug worked to improve their memory, and here we're doing memory scores, then we would expect that difference to be greater than 0. So they said the subjects were randomly assigned to treatment groups, so that should be fine. We have a before and actually we have two groups. We don't have a before and after. We have a treated group and we have a control group, so those are independent. Less than 10%. It's actually a pretty large sample. I think there's about 200 subjects altogether, but still should be less than 10%. And then nearly normal, we're going to check for both groups. We can do histograms or probability plots. Now, the textbook showed you the stem and the box plots. The problem with that is we can't really see modality. So let's go ahead and go back to the textbook and click here, and we're going to bring up the data set. Hopefully it will come up for us once in a while. I'm having some trouble lately with the All right, let's try to go this way. Sometimes they're not coming up from the ebook, so let's try this way. So we're in chapter 20. And we should be able to see this in here. Memory, it should be the memory data set. Okay, there it is. Okay, so the first thing I want to do is take a look at the histograms. And so I'm going to go ahead and select both variables. And I'm going to just have it do the same scaling so that they look comparable, and we'll hit compute. Now this one looks a little jagged, and I might want to try to smooth it out a little bit. And if I look at my bin width, it looks like it's 2.5, which is kind of a strange bin width. Let's go ahead and change the bin width maybe to 5. Let's take a look. So that looks pretty unimodal symmetric. Notice the frequencies. These are really large samples. This one looks fine. If you remember, if our samples were large, we really didn't have to worry so much about some deviations from that unimodal and symmetric. And so this one seems to have a little bit of a tail over here, but it's nice and unimodal in the middle. So I think we're okay. All right, so we'll say we met our conditions. I'm going to go ahead and do the test. So we're doing, now we're doing a T-Statistic, remember, and we're doing 2 samples, and we have the data. And so first we're going to pick the ginkgo. It's going to be in column 1, that's our first sample, and the placebo's in the second column. We're not going to pool variances. Remember, we never pool variances. And our null is that the difference is 0, and our alternative is going to be that it's greater than 0, because we hope that the drug helps the patient's memory. And so if we go ahead and look at our calculations here, we got a difference of, let's see, the T-statistic negative 1.54. The p-value is very large. And actually, it almost looks like the differences are gone in the other direction, because if you look at the mean difference, it's actually almost -1, meaning the mean of the ginkgo group is less than the mean of the placebo, leading us to believe that perhaps this drug is not doing anything for the memories. Let's go ahead and go back and do a confidence interval and just change over here. And as we notice here on the confidence interval, it goes from -2.3 up to +0.3. 0 is in the interval, which agrees with us not rejecting the null. But it might be of interest to the scientists to maybe go back and take a look, because it really doesn't look like the drug. It looks like the placebo group is actually doing better than the treated group.